We're back. Today we're going to talk about transform boundaries and divergent boundaries. Got Drew here to help me again today.
Hi.
And what we're doing is we have created some construction paper examples of plates and plate boundaries. So each of us has two models here of divergent boundaries. And if you look at each of these a little bit more closely, what you'll notice is that we have in black, the black line is the plate boundary. Okay, and the plates are on either side of that boundary. Okay, so we have several different designs of plates with plate boundaries. Okay, but all of them represent divergent boundaries. Okay, and so what we're going to do is on each of our models we have little markers that are going to show how the plates move relative to each other as we run this very simple experiment. So first, Drew, what I want you to do, because you know what divergent means, right? Divergent boundaries. So I want you to pick a place on each plate on either side of your boundary and just show with arrows with your marker what direction the plates move when they diverge. Okay, so your plate on the left moves to the left and your plate on the right is going to move to the right. Now if you look at those arrows, they are moving apart, right? They're separating. So I'm going to do the same thing, and what I want you to do is also add some arrows right on either side of the actual plate boundaries. So for me, I'm going to put one up here, one here to show that it's separating. And then like Drew, I'll add some big arrows to show that this is a divergent boundary and that the plates are separating. Okay? And then we can do the same on our other example as well. Put our arrows. Drew, do you want to add some arrows to your blue plate boundary to show divergence? Okay. Now we know which direction they're going to move. So now we're going to pick one of our examples, whichever one you like there, Drew. And we're going to put our hands on our either plate. So we've got two plates. Each of us has two plates. And we're going to start to slowly separate them. And you want you to keep your eye on these little markers and see how they move relative to each other, okay? So here we go. We're going to slowly start to separate. Divergent boundary. Okay, and what you should see here on both of ours, where the table shows through underneath, that's where we have our divergent boundary. We're opening up a gap. This is where magma comes up from underneath and fills in that gap in the divergent boundary. But if you look at this part of the boundary, the horizontal part of the boundary and our little markers, notice that they have not separated, but they have slid past each other. And this is what we call a transform boundary. So if I run that backwards again, put them back, the dots are right across from each other, and as I move the divergent boundary, those dots slide past each other. And so if we were going to add arrows to our transform boundaries to show the direction of motion right along the boundary, we could do this. We'd show that that plate moved that way and that plate moved that way. Okay, and Drew's going to do the same on his. And that's consistent with the direction that our plates moved. So in my example, this plate here moved off in that direction, which is consistent here because it's on that plate. And this arrow is consistent with the motion of this plate. Okay, so even though we have 1, 2, 3, 4, 5 different legs, you would say, or jogs in this boundary, this is all one boundary. It's just that these parts here that have separated are divergent, and these parts here, where the dots slid past each other, are transform. And now let's run it again, Drew, with our second example. Take your other plate. We're going to do the same thing. Just slowly start to slide them apart. Watch the boxes. It's a divergent boundary. The plates separate and the boxes slide past each other. And if we add our arrows right near the boxes, the arrows are consistent with our overall plate motion. So again, two plates, one plate here, one plate here. The overall motion is separating or divergent. And right there we've got localized transform motion, the transform boundary. And there you have it, transform boundaries along divergent boundaries. Thanks for your help.
Thanks.
See you next time.
Bye.